Jupiter, the biggest planet in our solar system. But it's not just massive, it's a mystery, a storm-soaked giant where the laws of physics go wild. Its magnetic field, out of this world. Its storms, defying chemistry. Jupiter isn't just a planet, it's a cosmic powerhouse. Let's peel back the clouds and see why this giant is way weirder than you think. Jupiter is colossal. With a diameter of over 143,000 kilometers, it's 11 times wider than Earth and could swallow 1,300 Earths inside it. If all the other planets were combined, Jupiter would still outweigh them all. Orbiting the Sun from 778 million kilometers away, this gas giant takes nearly 12 Earth years to complete a single orbit. Yet, despite that vast distance, Jupiter is one of the brightest objects in our night sky, visible even without a telescope. But here's where it gets weird. Jupiter's day lasts less than 10 hours. It spins so fast that it bulges at the equator, becoming oblate, not perfectly round. That spin supercharges the jet streams across its surface, creating raging belts of color and storms that can last for centuries. Jupiter isn't just a planet, it's a solar system in miniature. With 95 confirmed moons, it's like a cosmic empire orbiting one colossal ruler. Each moon is a world of its own, strange and alive in its own way. Take Io, a fiery sphere constantly reshaped by volcanoes. It's the most volcanic body in the solar system, with eruptions so violent they're visible from space. Then there's Europa, its icy shell hiding a massive subsurface ocean, a place scientists believe might host life. Ganymede, the largest moon of all, is even bigger than Mercury and has its own magnetic field, hinting at a buried ocean. And Callisto, ancient, cratered, and unchanged for billions of years. It's like a time capsule from the dawn of the solar system. Together, they orbit Jupiter like planets around a sun. Add the planet's faint ring system, and you get a miniature solar system, a vast, self-contained kingdom swirling within our own. When we talk about rings, Saturn steals the show, but Jupiter has its own, faint, dusty, and easily overlooked. They were discovered by Voyager 1 in 1979, later confirmed by Galileo and Juno. Unlike Saturn's icy rings, Jupiter's are made of microscopic dust, so dim they can only be seen when backlit by the sun. These rings form when micrometeoroids strike tiny moons like Adrastea, Metis, and Thebe, blasting dust into orbit. Over time, the dust spreads into delicate halos encircling the planet, almost like cosmic fingerprints. The rings are just a few thousand kilometers thick, but extend over 100,000 kilometers from Jupiter's center. They remind us that rings aren't rare, they're just hidden in plain sight. Jupiter has the same ingredients as the Sun, hydrogen and helium. That's why some astronomers call it a failed star, but that phrase is slightly misleading. To ignite like the Sun, Jupiter would need about 75 times more mass to start nuclear fusion. It's not that it failed, it just never had enough material to cross that threshold. When it formed 4.5 billion years ago, Jupiter grew rapidly, pulling gas and dust from the early solar nebula. Then, solar winds blew away the remaining gas before Jupiter could become anything more. Yet, it still behaves like a star in some ways, emitting more heat than it receives from the Sun. This comes from gravitational compression, called the Kelvin-Helmholtz mechanism. Jupiter is slowly contracting, releasing leftover heat from its birth. In infrared, it even glows faintly, a cold ember in space. Jupiter's magnetic field is the most powerful of any planet, 14 times stronger than Earth's at the cloud tops. It's so immense that if you could see it, the magnetosphere would appear larger than the sun in the sky. This magnetic field traps charged particles, creating a radioactive bubble around the planet that would fry any spacecraft not built for it. Inside this bubble, Io plays a crucial role. Its volcanic eruptions shoot sulfur and oxygen into space, forming a plasma torus that fuels Jupiter's magnetic power. The result is auroras that never end. Unlike Earth's auroras that flicker with solar storms, Jupiter's glow continuously, powered by its rotation and Io's volcanic gases. Through the Hubble telescope, they appear as ghostly ultraviolet rings encircling its poles, beautiful, violent, and constant. You've probably heard Jupiter called Earth's cosmic shield, a guardian that deflects dangerous comets and asteroids. That is partially true. Its massive gravity acts like a celestial gatekeeper, redirecting or capturing countless space rocks that might otherwise strike Earth. The most famous example came in 1994, when comet shoemaker Levy 9 smashed into Jupiter. The explosions were so huge, they left Earth-sized craters across the planet's clouds, proof of Jupiter's ability to take hits for us. But the story is not that simple. Jupiter's gravity can also sling asteroids toward the inner planets, occasionally sending them our way. It both protects and endangers us, a double-edged force shaping the entire solar system's history. In fact, even in our early solar system's life, Jupiter's migration may have triggered the late heavy bombardment, a rain of meteorites that plummeted the young Earth, but also delivered water and organic material that made life possible. So, without Jupiter's chaos, we might not be here at all. If there's one image that defines Jupiter, it's the Great Red Spot, a storm so vast it could swallow Earth whole. It's been raging for at least 350 years, possibly longer, spinning counterclockwise with wind speeds over 640 km per hour. Unlike hurricanes on Earth, the Great Red Spot is a high-pressure vortex, constantly fed by powerful jet streams that stabilize it. Over centuries, it's changed shape and color, from deep crimson to pale orange. Scientists still don't know what gives it that reddish hue. It may be sunlight reacting with chemicals like ammonia and acetylene high in the atmosphere. But here's the strange part, the storm is shrinking. In the 1800s, it was 3 Earths wide. Now, it's barely 1.5. No one knows if it's dying or just evolving. Some simulations suggest it might merge with nearby storms and rebound, while others think it's finally running out of energy. Either way, it's a window into Jupiter's wild weather, and a reminder that even on a world of gas, storms can outlive civilizations. Jupiter's atmosphere is like a perpetual war zone. Massive jet streams tear through the planet's belts, whipping up lightning bolts that dwarf anything on Earth. Spacecraft like Juno have detected superbolts, lightning strikes hundreds of times more powerful than ours, buried deep in Jupiter's water clouds. They illuminate the planet's night side like flashbulbs in the dark. There's also something even weirder, mushballs. These are giant hailstones made of water and ammonia, forming deep in the atmosphere and plunging downward before evaporating again. They act like the planet's natural air conditioning system, carrying heat and chemicals between layers. At the poles, the weather gets even stranger. Instead of a single vortex like Earth's, Jupiter's poles host perfectly arranged cyclones, 8 around one at the north and 5 around one at the south. They don't merge or drift, they stay locked in place, like a spinning geometric puzzle. Juno's images show them in motion, swirling, stable, and beautiful, held together by a balance of temperature, rotation, and invisible winds. If you could hear Jupiter, it would roar. Its magnetic field generates intense radio emissions, first detected in the 1950s. When converted to sound, they resemble eerie crackles and howls, the music of plasma and magnetism. These emissions aren't just noise, they tell us about Jupiter's inner workings, from its deep atmosphere to the shifting magnetic storms that wrap around it. Scientists even use them to study lightning patterns and plasma density inside the magnetosphere. Jupiter literally sings, and we're only beginning to understand its rhythm. Despite decades of missions, we still don't fully know what lies beneath Jupiter's swirling layers. The planet has no solid surface, just increasing pressure as you go deeper. Hydrogen, under extreme compression, turns into metallic hydrogen, a bizarre state of matter where atoms are squeezed so tightly they act like a metal, conducting electricity and fueling Jupiter's immense magnetic field. Below that may lie a fuzzy core, part rock, part metallic hydrogen, surrounded by layers that churn like boiling water. It's not a calm interior, it's alive with movement, releasing energy, heat, and magnetism that ripple up through the planet's clouds. Every spacecraft that visits Jupiter, Pioneer, Voyager, Galileo, Cassini, and Juno, reveals something new. Juno, orbiting since 2016, has given us our most intimate view yet. gigantic cyclones, ghostly auroras, and gravity data, hinting at a deep dynamic interior. And it's still not over. Future missions like JUICE, Jupiter Icy Moons Explorer, and Europa Clipper aim to explore the moons, not just to study Jupiter's system, but to search for life. Because while Jupiter itself is uninhabitable, its moons, especially Europa, might not be. Jupiter is a paradox, both protector and destroyer, planet and almost star, chaotic and stable. It's the reason Earth exists as it does, yet it holds mysteries that challenge everything we know about planets. Its storms could fit continents, its auroras never fade, and its magnetic field stretches further than any planet's reach. It's a reminder that even in our own backyard, the universe is stranger than imagination. So, the next time you look up at that bright star in the night sky, remember, you're seeing a world that controls comets, breeds lightning, and glows with the leftover fire of creation. Jupiter isn't just the king of planets, it's the heartbeat of our solar system, keeping the rhythm of chaos and order in balance. And it's still full of secrets waiting to be uncovered. If you enjoyed diving into the mysteries of Jupiter, don't forget to like, subscribe, and turn on notifications for more deep space stories that challenge what you thought you knew about our universe.